Hey there, my name is Selim.Digital, aka Mr. T, and today I'm exploring the concept of endothermic reactions. So, what exactly are endothermic reactions? Well, you can think of them as chemical reactions that absorb heat from their surroundings. In other words, they feel cold to the touch because they're taking in energy. So, in an endothermic reaction, heat is taken in, and so if you are experiencing or observing an endothermic reaction, you would feel a cold sensation. You might even notice something like frosting or a drop in temperature if you've gotten a thermometer. One of the most important reactions on Earth is an endothermic reaction. Photosynthesis, the process of plants absorbing sunlight and using that sunlight to convert carbon dioxide and water into glucose and oxygen as a byproduct, is an endothermic reaction. Now, in a lab, one of the most common reactions that we'll see at the high school level, and one maybe you tried in your sixth grade or science class, is the baking soda and vinegar reaction. It's a sort of classic experiment, and it's well tried because it's awesome. So, in the baking soda and vinegar reaction, we have a neutralization reaction occurring. So what we've got sodium bicarbonate, NaHCO3, a base, reacting with vinegar, acetic acid, also known as CH3COOH. And when you combine these two, they kind of duke it out, and what we would more commonly or scientifically call a neutralization reaction. And the process of that reaction absorbs energy from the surroundings, meaning that energy is being absorbed from the liquid and the air inside the bottle. So you will feel and observe a drop in temperature as that neutralization reaction is occurring. A byproduct of this is carbon dioxide gas is produced during the production. In an experiment, you can see it build up, and that causes an increase in pressure, and that's where you get all that exciting fizz. And if you have it under pressure, if you allow the pressure to build up, then you can get like an explosion of foam. So let's take a look at what I'm talking about in a series of demonstrations using baking soda and vinegar. We'll be looking at how the reaction occurs and seeing the buildup of gas. We're going to actually demonstrate the endothermic reaction and then demonstrate that the reaction releases carbon dioxide instead of some other gas. So what we're going to do is we're going to place the vinegar into the bottle. This smells wonderful. In my class, my students are going to be very excited about all of the scents that they will be coming into. And then I'm going to be adding the baking soda into the balloon. Now, the reason I'm doing that is because I want to be able to try and make sure that all of it successfully goes in. Woohoo! Now, I did not get a perfect seal on my balloon, but as you can see, the balloon is expanding as the fizzing is occurring, as the reaction is occurring between the baking soda, the sodium bicarbonate, and the white vinegar, which is acetic acid. Something is occurring. Something kind of fun is occurring. I'm going to place the thermometer into the bottle to see whether or not we notice any change. I can feel a temperature change. The bottle is cooler, and let's see if we can get some evidence to support this claim. Yes, we can see it. It is at about 20 degrees. So if there's insufficient oxygen, we shouldn't be able to maintain a flame. Let's see what happens. So I've got myself this beautiful flame, and I've got myself my baking soda and vinegar. magical! Combustion ceased because the carbon dioxide byproduct that was released suppressed or put a stop to the combustion. That's good because it was going to burn my fingers. All right, so to sum up the main point, endothermic reactions are like energy absorbers in the chemical world. So in this case, what we're seeing is that they're taking heat in from their surroundings. And as these reactions progress, energy is being absorbed. And that includes, in this case with the baking soda and vinegar, the energy from the liquid and the air that was inside of the bottle. I hope you had fun watching it. I certainly had fun doing the demonstrations. I really do encourage you to try these at home yourself. I mean, YouTube is wonderful, but there really is no substitute for seeing reality in person. I'm choosing reactions that are cheap and easy to do and safe, and things that you can really do with household supplies. This is a tremendous amount of fun for students and chemistry fans of all ages. And philosophically, I think that's sometimes we spend too much time trying to learn chemistry on paper, balancing equations and things like that. These are important concepts, but fundamentally, the real value and why chemistry is worth learning is because it allows you to see a lot of really cool and beautiful things. Fundamentally, the purpose of science is for us to be able to explore and appreciate the beauty of the world. So, as I finish this video, really what I hope for each and every one of you is that you stay curious. Appreciate the fact that there's beautiful things out there and there's really cool things out there. And as long as you're staying curious and observing the world around you, you can really derive a tremendous amount of joy. Don't just be satisfied watching a science teacher do this on a video. Go try it yourself. Observe it and just feel the excitement of seeing something cool. All right. Always a good time, and I guess I will see you at the next video. Take care.